Hello, in this video we are going to look at an area problem in coordinate geometry. So let's take a look at the question. The line L1 has equation y equals 2x minus 1. The line L2 is perpendicular to L1 and goes through the point 4, 2. Find the area of the region enclosed by the lines L1 and L2 and the y-axis. Alright, so a picture is really worth 1,000 words here, so we must start by considering what this whole situation actually looks like. So it's a very good idea to start with a very rough sketch just so that you know what you need to do. So let's try to just do a rough sketch of some of these lines. So what do we know? We know that L1 has equation 2x minus 1. Okay, so y-intercept of minus 1, a gradient of 2, it's going to look roughly like this. And it doesn't matter if it's not perfect, this is just to help guide you to see what you need to do. Line L2 is perpendicular to L1 and goes through the point 4, 2. So 4, 2 is maybe somewhere around here. And it's got to be perpendicular to L1. Okay, so perpendicular and going through that point, that means it's going to look something like this. Okay, that's not a very good straight line, but you'll do a better job. There's L2. And, okay, and what we're looking for this region in here. Now, in order to calculate the area of this region, which is just a triangle, what I'm going to need to know is a sort of base times height way of thinking about it. Well, we could sort of rotate this triangle round in our heads, maybe, so it's oriented like this. And if I knew what this base was, and I knew what this height was, then I'd be able to calculate the area. Well, the base is just the difference between this y value and this y value. And the height is, well, the difference between the x value at this line, which is 0, and whatever the x value is here. So what do I know already? Well, I know the y value here is minus 1, because that's the y value here. I don't know the y value here because I don't know what the equation of this line is, and I don't know the coordinates of this point either. So it seems like I'm definitely going to have to work out the equation of L2. So let's just go ahead and do that now. Well, I know that the gradient of L1 is 2, and if L2 is perpendicular, then its gradient will be minus 1 divided by 2. We're using the minus 1 over m formula. So there's the gradient of L2, minus 1 divided by the gradient of L1. So I know it's going to look something like y equals negative a half x plus c plus something. And now I need to use this point here to help me work out what c is. Now, if you're comfortable with this from previous video, I encourage you to pause the video now and try and do this bit yourself. Okay, so I'm going to sub in the values. So when y is 2, I'll sub in an x value of 4. And I still don't know what c is, so expanding that bracket, I get minus 2 plus c, and if I add 2 to both sides, I've got that c is 4. So that means the equation of that line is y equals minus a half x plus 4. Alright, so immediately I know that the y-intercept of that line is 4. So I now know that this is 4. But that tells me that this whole length must be 5. That's the gap between negative 1 and 4. So I've got my base. Okay, all I need to do is establish the height, and that's this distance here. Well, I know the x value here is 0, but what's the x value here? Again, pause the video, see if you can figure out what the x value is at this point. Okay, so this point is the intersection of the lines L1 and L2. So I can just do some simultaneous equations really. Now we are going to be looking at simultaneous equations later in the course, but for now, all you need to know is that if you've got y equals 2x minus 1 for one of the equations, and y equals a half x plus 4 for the other, you can just equate 2x minus 1 with a half x plus 4. setting them equal to each other finds you the point when they're both true, and that is at this intersection point. Okay, I can add half x to both sides, so that gets me 2.5x here, and I can add 1 to both sides, and that gets me 5. Dividing both sides by 2.5, I'll get that x is 2. Okay, I'm not sure I even need to bother subbing in to find a y value, because I only really care about the x value here, but I'm going to do it anyway, just for completeness. So if I sub that value of x when it's 2 into either one of the equations, but let's do this one, 2 times 2, because x is 2, 2 times 2 is 4, minus 1 is 3. Okay, so I now know that the coordinates of this point are 2, 3. And that tells me what I need to know, because it tells me that this distance here, x is 0 at this point, and x is 2 at this point, so this length here is 2. So my height of my triangle is 2. Alright, so now we're in a position to solve this because we know that the area of a triangle is half times the base times the height. Now, half times 5 times 2, 5 times 2 is 10, and 10 times a half is 5. So I've got that the area of this region is 5 units squared. Now, it's always worth, particularly at this stage, just sketching this stuff out on some graphing software just to see if we were correct. So let's plot this line. So I've plotted the original line here, y equals 2x minus 1. And let's plot the other one as well. So we calculated the perpendicular one had an equation of minus a half x plus 4. Okay, so we can now look at this region and say, okay, we did get the right coordinates here, which is good. And we can see the area of this triangle is half times this length here, which is 5, times this length here, which was 2. And yes, indeed, that was an area of 5 units squared. Alright, so I hope you enjoyed that video. I hope you enjoyed seeing how some techniques that you already know can be brought together to solve some slightly more sophisticated problems. In the next video, we're going to be looking at modelling using linear equations. So I'll see you there.